Okay, so on Friday, I told you how to find the possible roots. You're going to use that today. We're going to use the possible roots in synthetic division to find all the rational roots. Okay, so we're going to do example 1. Example 1 is f of x equals x to the third plus x squared minus 17x plus 15. So the big part is making sure you understand the directions. So for this one, it says find all the rational roots. Rational roots are your integers like -2, 2, it could be a fraction, any of that, where you can actually have like x plus 3 equals 0 and you solve for it. Irrational root is something with a square root, and an imaginary would be with an I. All I want are those ones without square roots and without i's. So, just a reminder that p is the constant term. So, which one is the constant term? Okay. And then q is the leading coefficient. What is the leading coefficient? So, p now is 15. We're going to list the factors of 15. Remember, factors come in pairs. And I don't want you to jump all around. I want you to be consistent. So, what are two pairs starting with the smallest number that goes into 15? 1. So, roots come in pairs. So, a positive 1, a positive and negative 1, a positive and negative 15. What's another pair of factors that go into 15? 3. So remember, they come in positive and negative 3, positive and negative 5. Are there any other factors of 15? What are the factors of 1? So positive, negative 1. So now we're going to write our possible roots. Possible roots are p over q. So we're going to take p, we're going to put them over q. So plus or minus, plus or negative, positive or negative 1 over positive or negative 1 is? Okay. Now when you list your possible roots, we want to put them in order from smallest to largest. So now, positive or negative 3 over positive or negative 1 gives you positive or negative 5 over positive or negative 1. And then positive or negative 15 over positive or negative 1 is? Okay, so you guys, the rational root theorem says these are all of our possible rational roots. So these are the only numbers that could be rational roots. So could 2 be a rational root? It's not listed. It will never be, it's never a root. It can't be. So now what we're going to do is we're going to use synthetic division to test these. Just like we did about 2 sections ago. So we're going to start with positive 1 because that's the first root. So we're going to put 1. And then we're going to do a synthetic division problem. Okay, here we go. We're going to bring down the 1. What is 1 times 1? Okay. What's 1 plus 1?
2.
What's 1 times 2? 2. What's negative 17 plus 2?
Negative 15.
1 times negative 15? 15 plus negative 15?
0.
So is 1 a root?
Yes.
How do you know it's a root? Because 0 is our remainder. Okay, so now what we're going to do is we're going to rewrite this. It was x to the third, so we're going to rewrite it as x squared plus 2x minus 15. We're going to see if that's factorable. If it's not factorable, then we have no more rational roots. If it is factorable, then we should have some more roots. So what is a? What is B? What is C? So I'm looking for two numbers that when I multiply, I get negative 15, and when I add them, I get 2. Since negative 15, since that is negative, I am looking for one positive and one negative. So what are two numbers you can multiply to get negative 15? So I have negative 3 and 5, positive 3 and negative 5. What is negative 3 plus 5? Positive 2. Is that the one that I want?
Yes.
Now, do I need to write it as a factor by grouping, or can I go straight to parentheses? How do I know I can go straight to those parentheses? Because A equals 1, so we're going to write x minus 3 and x plus 5. Are those factors or roots? These right here. They are factors because they're still in parentheses. So we need to find the roots. So what is the root of x minus 3? Positive 3. What is the root of x plus 5? Okay, so that means our rational roots, it says find all the rational roots. Our rational roots are the 1 that we found, the 3, and the negative 5. So our answer for this question is, it says find all the rational roots. This is our answer. We just found all the rational roots. So you guys, if you got down to this and you couldn't factor it, it was prime, then you would have no more rational roots. You would either have irrational or imaginary. What? This right here. If I couldn't factor that, that means there's no more rational roots. It's either going to be imaginary or irrational. So it just depends on whether or not that's factorable.
It would still be 1, right?
Yeah, we would still have the 1 because that gave us 0. Yes.
You don't get a 0 at the...
Then you have to test the next one, which we're going to do. I'm going to show you which one. I'm going to show you another one.